are currently using, use this approach. Then eventually, if needed, goes to the separated. So to do that, the process, the system API provide fork and EXEC. Sometimes name may be barriers, like the free fork, free EXEC, and something fork, whatever. But basically, they are using the fork and EXEC. And the Windows API, it uses create process. However, the system library is the same as this one, combined into two, which means fork is first when you create the process. So if you want to separate if you want independent from the parents, you need to first find space, right? If you do not find any location or space, you cannot move it. So during the fork, it finds some memory space for the child. However, this is not separated from your parent process. Okay? Still share what? This part, text part. The text part is shared because most expensive part of the creating process is I/O. Copy your instruction into the memory. So we take out that part, only share until when? Because we do not know whether you decide to move out. But if you cannot find the location, you need to back, right? So you cannot reserve the moving company or everything. No. Once you decide the location, once you find the location, then you can move and you can reserve the U-Haul, whatever. So that is a similar situation. Once you find the memory location, what if you cannot find the location? It will be error. You cannot create the process. That happens because the memory is limited resources. So once you find, then we can move it. So this fork first, so we have the parent process. So parent process is going on, but when we create the child process, it's using fork. So fork means finding the location, memory location. Okay. Then what about the child process ID? Is it created? Yes. The system, operating system has all the information about the child process, except the text part, instruction. So finally, we are ready to move it. So then next, the EXEC. So EXEC copy, during the EXEC copy, all binary code into the text. Then it will be separated. So this will be separated process. So this is the fork and EXEC. What about the create process? Actually, create process combine these two steps together. Then another thing is, what about the parents? While child process is running, there are two options. One is if you are playing outside, your parents wait until you return. Do not eat and don't do anything until you return. There may be one thing. So that is called the wait. Your parents wait until return. Okay? Return means terminated. Or another option is your parent is doing whatever they want. Okay? Then just once this process is done, just give the signal. We are done. Which one is more popular in operating system? First, wait. Second, not wait. So wait. So if you type a certain command, can you do other thing? No. So waiting until return. Think about the last exercise when you type for example, BC, calculator. So can you do other thing? No. Your shell program is waiting until child process is terminated, exit. Okay. However, sometimes you can continue your job even though the child process is running, like the background process, service process is running forever. So that is the how the process is created. So we can use the fork and EXEC. Okay. So let's take a look at. So there are the short-term different types of scheduler, but we are interested in the such a short-term scheduler. In other words, it's called the CPU scheduler. Okay, in chapter 5, we will see details. Okay. So to create the process, so we are going to use the system library fork and EXEC. So what is the purpose of the fork? Find the location resource. If that is successful, then we can run the EXEC. EXEC load its own code to the text area. Okay, it's always a two-step. Basically, the Windows follow the same step. But as you can see, most of the time nowadays, fork, then EXEC. And most of the time, when we have very limited resource, 20, 30 years ago, so even during the fork, it has been error from time to time. But nowadays, most of the time, you have the space. So the Windows decide to combine into one, that is a fork, then EXEC, then the create process. Okay, so this is just a slide to show the how fork and EXEC is working. During the fork, it's shared. Okay? But during the EXEC, it will be entirely separated. Okay, finally, we will have such a process tree. What about Windows? Windows has the same process tree. Have you ever seen? Yes? Let's take a look at it. So this is our virtual machine that we created. So how can we see the list of process? PS command. So first, so if you type the who am I, this is the current this shell. So as a user, okay. And if you type the PS command, PS shows only current the process information. In this case, the bash shell is the process ID is 3589. So this shell program is the 589. Then it create. When I type the PS command, PS is the child process of the 3589. Okay. During that time, fork and EXEC were executed. Okay. Then I try to see all the command, all the processes. Then we can use the PS minus EF, but that's not more, so you can see. There's such a process list. So let's take a look. First one is process ID 1. This is what? This is a kernel process. Kernel process create what? You can see the PPID. PPID is the parent process ID. But what is the parent of God? So God. So it's a 0. We sometimes use a 0. So there are two kernel process. This is the system kernel, but this K thread is the kernel thread because the operating system uses thread mechanics, thread data structure. We will discuss the detail of such a thread later. But anyway, this is the init process. There are two init processes from this kernel thread. So the other will be created. So this kernel thread created. Most of them are system process to operate your operating system. And you can see some like that. So this is my process, PS minus EF. So 3754. Parent ID is 3589. So 3589 is where? Here, the bash shell. So bash shell is, who create the bash shell? 3588. 3588 is the because I'm using SSHD. So what does that mean? D here. Usually most of the process name ending with a D means it's called daemon process. So what is the daemon? God? It's quite similar. What is a daemon? Daemon means, yeah, it's a process. Everything is process here. But different types of process, you can see some of the process ID, a parent process ID is 1, right? So this one, like if you see the SSHD, parent process ID 1. However, actually, who created the SSHD? 1? Maybe not. However, for example, if you start the child process SSH, for example, okay, you start the secured shell, the program started. It's a service program. But if you terminate, if your parents terminate, what happens? Child process will be terminated. Okay? Which means, if you log out, I try to learn the 24 hours, the 7 days a week, the 365 days, forever running the program. But you need to log in forever because you start that program. So I want to log out. How can you log out? You need to disconnect your parent and child relationship. Instead, this process, parent process ID will be 1. Intentionally change it, parent process ID. It can be controlled by kernel. Then at that time, this process will be called daemon process. So daemon process is the same concept as service process. When you're in the Android phone or in your Windows, it's a service program. It's running forever until operating system is the down. Okay? So that is the daemon process. Keep in mind, there's another similar thing later. Soon. So this is the process. It's a little bit hard to see the So to see the two-printer process, this is a manual page. I suggest to use the manual page whenever you encounter, if you are curious which option is EJH. If I type PS minus EJH, you can see, for example, this is my process, and this is a batch, and this is started by the this SSHD, and this one, finally there the parents is, if we go up, there's a kernel thread. So kernel thread start, then next one is the SSHD, then another SSHD. I don't know why it is the create this one, probably secure the reason. Then the finally batch shell and the PS. This is the last terminal process, like that. So you can use this one. And also, if you are interested in the Windows, there's a Windows application, like it's a PS list, it's a third party, the application. It's not in Windows operating system. This one also shows the PID and the PPID. So if you want to see the tree, so PS minus help, PS list minus help. So what is the option as a tree? So minus T, I think, or minus T. So you can see the last one, where is the PS tree? PS list, yes, PS list is here. So this is a last command, and parent is a CMD. And the CMD is started by what? Explorer. Okay, Explorer is started by kernel process. It's a Windows used the exactly same mechanism. Okay. Then, so this is a process 3. And as this is the diagram that shows the life cycle of the parent and child. So, parent can wait until the child process is terminated. Then once it is terminated, exit, then it will continue their own job. So this is one of the simple example how to create the child process. Any creating process use the same thing. This is actually the starting point of your project 1. Okay, in your project 1, you should be able to create a child process. That's the shell program, right? So you can use this process. Let me quickly explain, then we are going to have the VI exercise lab. So, fork system library, and what happened? Find the memory space. And if you can find the memory space, return the process ID. Sometimes it will be 0. 0 means, so it's a successful to the user. Or sometimes it will be less than 0, negative value, that means it's error. You don't find. You cannot find. So you need to take care of the error. So fork fail. Then problem is, during the fork, what happened? So exactly same. Okay, 2 instructions will be running concurrently. So don't be confused. Because of the some of the students confused, until EXEC, the parent process instruction, child process instruction are the same. They are running concurrently. Okay, so because of that, some part will be used for parent, some part will be used for child. Okay, this code has both of them. So if successful for the child process, then we can load the binary code command, like in this case ls will be exec, and this will be exec. First time it will be the same, and during that process, it will be the ls instruction will be loaded and will be separated. Okay, then for the parent process, we need to wait. Parent process should wait. This will be used for parent process. Then, so if you want to test it, I think I strongly suggest you to test this code. I already, there's that. So this is the same code as this one. You can see the fork, then using the return code of the fork, so we can do the whether failed or whether the exec for child process or the wait for the parent process. So if you learn this one, I already compiled. The child completed, which means it's a child successfully. Child process is created. Then it's done. So there actually there is no. Or you can see the command like this one. It's an ls command. Okay. This is an ls command. The return of the ls command, list of the file a.out and the .c file will be returned from child process. So it creates the child process and load the ls command, and ls command is executed. Then that is completed. Then what about the parent process? It's still waiting the input. It's running. Okay, so that is the fork and exec. That will be 90% part of your project one. If you can understand this one, and the others are checking the addition housekeeping. Okay. Last slide today. So this is the Windows. Windows is the same thing, but it has a create process. Create process has both fork and exec. Then it load the MS Paint in this case. So this is the exec part. MS, the Paint will be loaded. There are some other options, okay, we can use, but this time most of them are not. Then create the process and wait until child process is done. So wait for signal. It's the same as wait. Okay. So this is an example of the Windows and the Linux and so on. Okay, next time we will continue process termination as well as once we have the multiple processes, the next step is we should be able to communicate each other. So because for one task, one job, there might be several processes working together. So problem is how to communicate. So are you using? Are you happy? Okay, so please go into the console. Okay, then select the project that you create. Then select the compute engine. If you do not know where is the compute engine, always type the compute engine on the top menu bar. Okay, then if you go to the compute engine, you have the available instances there. Probably you create the one. If you create the server, there might be several instances. Then in the middle of the line, there is a SSH. Click the SSH. Okay. So in your project, if you implement and submit based on the local computer, it will be automatically zero. Okay. Do not later argue I did everything and even better on the local machine. I'm not going to accept. Please use the virtual machine that you create on the GCP. Okay. So if you do not create the virtual machine yet, please create. Okay. So you don't have to wait. So try it. For your practice, you can create as many. Actually, up to 12 projects you can create. There might be some, but it's pretty much enough. So try and delete. Try and delete. If you have any question, raise your hand. Go ahead.
Before going into the VI, I just need to discuss about the file permissions.
Do you need this one?
No, that's okay. In the first column, you could see that there are 10 bits. You see the first one. The first bit denotes whether it's a file or directory. In the third column, the D denotes the directory, and it can be socket and some other. Mostly it will be the directory or the hyphen. So we can just omit the first one and see the next 9 bits. In the 9 bits, the first 3 responds to the user or the owner who created the file, and the next 3 denotes the group in which the user present, and the last 3 is the others who are all remaining apart from the user and the people in the group. If you want to change the file permission, you should use the command chmod. It's of like who and the operator and the permission and the file. So chmod is to change the file permission, and who is whether the user or the group or the others. And the operator is like whether you need to add any permissions like read, write, or the X is the executable one to run the shell or program of your file. A permission is like read access, write access, or the executable access. File name is the file name. So if I need to give the PBB file to the executable one for the user, it will be like this one. Who is the user? I need to add, so I'm giving plus executable permission and the file name is. This is a command. Let me show you. And the file. You will see in the first one, for the user, the executable permission has been given. What if I need to add the write permission to the others for the large file? What will be the command? Can anybody tell? For the large file, what I need to add the write permission to the other group. Plus X.
No. Oh.
I need to add the write permission.
Oh yeah. Plus R.
You will see that large permission has been added.
If you do not have any files on your directory, so you can use the touch command. Why don't you touch, then file link. Touch command to create the empty file with the name. So it is very useful to create the null file. Then you can practice the permission with that file. But you may realize that when you create a file anytime, there is a default permission. But you can change such a default permission using umask. Mask is always masking to decide the default format. So umask, using the umask, you can change the default format.
The PS hyphen here will show what are the active process available in your SSH, and the first column denotes the user, and the second column is the process ID of the process, and the third one is the parent process ID, and the fourth column is the CPU utilization time, and these are the commands. You could see that this is the command I have typed. This process ID is 10180, and the user is my name, and its parent process is like 9593. You could see that 9593 is bash process. And regarding the foreground and the background process are the process which are running in your screen, and the background process is like it will be running behind the screen. So how to start a background process is just give the command you need to execute and ampersand symbol. This will start the process as the background one, and if you want to see what are all the background process running in your SSH, give the command jobs. It will show what are the process as a background. And if you want to see the background process in your screen, just give the FG command. It will bring the what are all the background process into the foreground screen. And to stop the foreground process, just give Control plus EZ. I will show
That's how to avoid the wait command. So parents always wait. The children terminate. But if you want to go for the next command, you can run the command with ampersand, which means wait will be suspended. So you can go on the next command as a parent.
I'm going to start the binary calculator as a background. It has been started and the process ID is 10212. Now if I'm giving any command, it won't work because it's running as a background. For the time, it has been stopped. So if you need to see what are the background process, just give jobs. It will show that PC. Actually, I started PC while coming here, so it shows two binary calculators. And if I want to use one, I just give FG. I can use, but I am getting the error like first time the FG is not working, so I just give the Control Z and type the FG command. Now the calculator is working fine. Just give Control Z to stop the foreground process. And if you want to terminate intentionally, by give the kill command, kill -9, and you should give the process ID, which is 10212. Actually, while creating it showed. Otherwise, if you want to know the process ID, just give PS-E.